Below you is Port Sutton near Tampa, Florida. This is Comco's first full-scale composite fuel production plant, capable of mixing coal pulverized ultrafine particle size with residual fuel oil. Coal arrives at Comco's plant by railroad hopper cars. Pre-crushed coal to -3 inch is received from A.T. Massey Coal Company. This elevating conveyor belt subjects the arriving coal to magnetic separation, where tramp metal is removed prior to fine grinding. The coal then continues on up a series of conveyors and is ultimately delivered to stockpile. The coal is stockpiled in the open by means of a radial stacking conveyor. Coal recovery consists of a front-end loader, which recovers the coal from stockpile as needed and transports the coal to a feeding hopper, which is equipped with a bottom vibrating output feeder that regulates the flow of coal into the primary crushing circuit located to the left. An elevating conveyor drops the coal into this Williams number 240 reversible impactor, where a primary reduction to -1/8 inch is achieved. After crushing, the coal drops by gravity into the bottom conveyor, which then elevates the coal to storage bins. This overall view shows the feed hopper to the left, elevating conveyor to the crushing tower, and a product elevating conveyor shown to the right. The Williams impactor has reduced the coal to 90% -1/8 inch at a rate of 60 tons per hour. The coal then drops into these storage bins shown in the background, prior to feeding to the Williams pulverizers shown in the foreground. We are now looking at a gravimetric feeder which is feeding each pulverizer at a rate of 7.5 to 10 tons per hour, resulting in a total production in excess of 30 tons per hour. All startup, shutdown, and operating functions are monitored by this Williams analog control panel. Automatic and manual mode operation is optional. This is the feed control gauge that displays the mill's bed depth of material in inches of water column. Next to it is the display of the 500 horsepower drive motor amperage. This gauge gives the mill's rotational speed, or RPM. The mill speed is adjustable utilizing this trim pot. This overall view of the Williams micronizing pulverizer shows the main air circulating fan and its drive to the left, while below the pulverizer we have the power drive skid. This is the standard torque 500 horsepower drive motor coupled to a Lewis Alice water-cooled electric variable speed clutch, which in turn is coupled to a Falk right-angle gear reducer. By utilizing standard components, Williams has designed an isolated drive system which cannot be contaminated by coal and which is readily accessible for system maintenance. An air-to-water heat exchanger is provided for the electric clutch. Here, the dissipated heat energy is removed from the closed-loop cooling system. High ash coal, up to 40%, and hard-to-grind pyrites and tramp metal are periodically unloaded down this reject chute, as simulated in this picture. Leaving the drive system, we now approach the pulverizer's airlock feeder. This feeder runs continuously and provides an even bed of coal as called for by the differential pressure controller, located back at the control panel. At the same time, it prevents the egress of oxygen into the system. Processing 15 to 20 tons per hour of coal, the Williams micronizing pulverizers are grinding the coal to a fineness of 98% minus 325 mesh. Of course, part of the overall design parameters were to allow for ease of maintenance. Shown here are the oversized access doors located in the pulverizer cover. What you just heard was the startup of the 500 horsepower motor. The motor starts unloaded as the clutch is not as yet activated. By manually adjusting the clutch trim pot shown earlier, variable speed can be achieved to optimize the pulverizing conditions. Operation of the pulverizer in an open condition as shown is not recommended. There is always a chance of fire or explosion. Normal operation with the door closed is with an oxygen level of 8 to 9%. Complete access and removal of the pulverizer journals can be made through the access door. The air system is comprised of the main fan, shown to the left, which causes the fine ground coal particles to be elevated from the pulverizer to the spinner separator. This is an active classifier and has a remote variable speed drive that allows accurate classification of the micron coal. Once sized, the micron coal is then conveyed out of the spinner separator and over to the cyclone separators, where the coal is centrifugally removed from the air. The cyclone separators cause the coal to disassociate from the airstream and discharge by gravity out the bottom outlet. Adjacent to the cyclones is a baghouse that is utilized to remove substantially all coal particles from the airstream that have escaped the cyclone separator. This baghouse product then is screw conveyed over and airlocked into the cyclone product discharge. Contingency planning dictated that besides the control of the system oxygen content, provision should be made for a possible malfunction. To that extent, explosion venting has been provided on all cyclones and ductwork. The coal discharging from these cyclones at a rate of 15 to 20 tons per hour drops below into a tank where residual oil is mixed to produce a fuel oil mixture called COM or COM. This plant is designed to produce 3,000 barrels of coal oil mixture per day. The ultra-fine, 98% passing 325 mesh particles, is comparable to talcum powder for fineness. These ultra-fine coal particles remain suspended in the oil after once being mixed, removing the need for chemical additives. Other advantages of this ultrafine particle size is the minimized erosion and abrasion of the customer's boiler system and equipment, as well as the reduction of boiler ash-related problems.
And zero it out, yeah.
much you gonna shake in there?
About 7 grams would be good. Man.
6 or 7 grams. That's 0.5. There's 6 there. And put it on your Alpine. The coal particle fineness is constantly checked, and the spinner separator particle sizing system has proven to be very accurate and will hold the product size within 0.5% of 1%. The heart of the pulverizing system is the Williams patented inert gas system, comprising of the main fan to circulate the relatively inert gas, the exhaust fan used to remove the steam-laden gases, and the baghouse used to clean the gases prior to discharge, and the air heater used to generate the drying and inert gases, and the panel-mounted oxygen analyzer used to monitor and alarm the system on excess oxygen. This then is the Williams combination number 6 oil or natural gas air heater. This heater generates 6 million BTUs per hour and allows simultaneous drying and grinding of wet coal. This system will dry wet coal with up to 15% free moisture. An analog temperature recorder is supplied so as to control and monitor the system temperature. Furnace outlet temperature is also monitored and alarmed. By burning the oxygen out of the air conveying system, a relatively inert hot gas is developed. The heat is utilized to dry the coal while it is being pulverized, and the inert gas provides a safe operating system. This system is being operated at 7% oxygen level, which will prevent any explosions or fires. And so the Port Sutton plant has demonstrated that coal oil mixture can be handled much the same way as oil. Here we see a 20,000 barrel tank barge being loaded for shipment across Tampa Bay to Florida Power's Bartow 125 megawatt generating plant, which has been retrofitted to burn COM. To date, over 200,000 barrels of COM have been burned with great success and right on target.